All right, welcome to day 5 of your 100 Days of Code. Today, we're going to tackle a mistake that trips up every, and I mean every, beginner. It looks like a bug, feels like a bug, but it's not. It's a fundamental concept you're just not seeing yet, so pay very close attention. So, a student came to me with this exact problem just the other day. Totally stumped. They did the math, checked it twice, couldn't figure out for the life of them why the computer was wrong. Well, guess what? The computer wasn't wrong. Let's break this whole thing down so you never make this mistake again. Okay, let's get into the code. First up, we assign a value to a variable we'll call a. But look really closely here. We're not just assigning the number 1. We are assigning the character 1 because we've put it inside quotation marks. That's the key. And then we do the exact same thing for another variable, b. We assign it the character 2, also wrapped up in those quotes. Now to you and me, a and b look like numbers. But to Python, it sees something completely different. So now we tell the program, hey, print the result of a plus b. You're expecting 3, right? I mean, it's just simple math. But watch what actually happens. The output is 12. And there it is. That's the moment where everyone gets confused. But listen to me. This is not a bug. Your computer has not forgotten how to do math. You've simply given it an instruction that it interprets in a way you didn't intend. Let's fix that right now. You see, the problem here has nothing to do with the math. It's all about the data types. You told Python you were working with text, and Python, well, it's very literal. It did exactly what you told it to do. And here is the absolute crucial point. Anything you put inside quotation marks is treated as text. In programming, we call that a string. So for Python, the string 1 has no more mathematical value than the letter A or a $sign. It's just a symbol. This right here really shows you how Python is thinking. When you use that plus sign on 2 strings, Python isn't doing addition. It's doing something called concatenation. It's a fancy word that just means it sticks them together, side by side. It does the same thing to 1 and 2 as it would to code and width. It's not math, it's just assembly. So how do we fix it? Simple. We, the programmers, have to take back control. We have to explicitly command Python to treat these characters as the numbers they represent. And this incredibly powerful technique is called typecasting. I want you to think of it like this. You are literally recasting the role of your data. You're pointing at the string, 1, and saying, hey, you, stop acting like a piece of text. From this moment on, you're going to behave like an integer. You are in charge of this conversion. And here's exactly how we do it. We take our string variables a and b, and we wrap them inside the int function. This is a direct command to Python. It says, take whatever is inside these parentheses and do your absolute best to turn it into an integer. And just like that, Python sees the number 1 and the number 2, it performs actual arithmetic, and it gives us the correct answer, 3. Okay, so while you often have to be very direct, sometimes Python is smart enough to help you out. It can actually perform typecasting for you, automatically, right behind the scenes. This is what we call implicit typecasting. Let's look at another example. Imagine we have 2 different kinds of numbers. First, we have c equals 1.9. Because it has a decimal point, we call this a floating point number, or a float. Then we have d equals 8, which is just a standard whole number, an integer. So what do you think is going to happen when we try to add these 2 together? The math is easy, sure, but think about the type of number we're going to get back. Is the answer going to be an integer, or is it going to be a float? The result is 9.9. So what happened here? Well, Python automatically converted the integer 8 into a float, 8.0, before it even tried to do the addition. It did that all by itself, without a single command from us. So why does it do that? It's simple, really. To prevent losing data. Python has a sort of data type hierarchy. Floats are considered higher than integers because they hold more information. You know, the stuff after the decimal point. If it converted 1.9 into the integer 1, you'd lose that 0.9. So, to play it safe, it always promotes the simpler type to the more complex one. It's a logical safety net, not some kind of magic. However, and this is a big however, this power has its limits. You can't just convert anything into anything else. If you try to break the logical rules of data, believe me, your program is going to break right along with it. For example, what do you think would happen if you told Python to convert a word like Harry into an integer? It's a ridiculous request, right? There's just no logical number equivalent for that string of letters. And boom, your program crashes and spits out a value error. Now, don't look at this as a failure. This is actually Python protecting you. It's correctly saying, hey, that instruction is completely illogical, and it's stopping you before you create unpredictable results. It's a feature, not a bug. And this right here illustrates the fundamental rule perfectly. The value you are trying to convert must be a valid representation of the data type you are converting to. The string 34 only has characters that represent a number, so yeah, that works. An integer can always become a float. But a string that's just a plain old word, nope, not gonna happen.
Okay, that was a ton of information, but this is an absolutely critical concept. Let's do a quick recap of the two types of casting you need to burn into your memory from today's session.
First, you have explicit casting. This is when you, the programmer, are in charge. You use a function like int to force a conversion. Second, you have implicit casting. This is where the Python interpreter does the work for you automatically to preserve data when you're mixing compatible types. Always, always be mindful of your data types. From this day forward, whenever you run into a strange bug, the very first question out of your mouth should be, what data types am I actually working with here? Understanding this is the difference between hours of frustration and a program that just works. Now, go practice. You're in control.